The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. And now, the man who takes the BS out of BS, Bill Spohn.
Welcome back to another episode of the Building HVAC Science Podcast. What's our goal? To help create better and more knowledgeable HVAC and building performance technicians by helping the two professions to better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. I've been working in these areas of HVACR and building performance for over 30 years and met a lot of interesting people with a lot of interesting stories to tell. Some of it a little techie, some of it not. Today we chat with Bill Graber and Steve Rogers of the Energy Conservatory, also known as TEC, T-E-C, a 40-year-old company that's on a mission to unite the tools and test instruments used in the HVAC and weatherization markets. Aha! That's an important quest I'm also dedicated to, as you can tell from the last sentences I said. We'll talk about what innovation means at TEC, and they'll be giving some examples. Now, the dictionary says innovation is the act or process of innovating. Okay, but so what is innovating? That's, again, dictionary says to make changes in something established, especially by introducing new methods, ideas, or products. To introduce something new, especially a product. Aha, that's it. It's really the action or activity that's important. We'll learn from Bill and Steve about the challenge of creating something that is neat, which engineers like myself understand you can create something because you could, versus creating something that is neat and useful to the customer. This is a rare peek inside the doors of a manufacturer, into their R&D labs, and into the brains of an innovative company, discovering the challenges and types of decisions that need to be made to satisfy their customers and advance the trades. There's some links we talk about during the podcast. They're also in the show notes. Hope you enjoy this episode. I had a lot of fun recording it. Good afternoon, guys.
Hi, Bill.
Afternoon.
So you might recognize the voices. I'll let Bill Graber go first and tell us where you're from and what you do at your company.
Yeah, okay. Thanks, Bill. So I am essentially the marketing guy at the Energy Conservatory. I do some other things too, but I joined the Energy Conservatory about 3 years ago, but have known about it for longer than that. And I've known Steve Rogers for over 30 years now. Yeah, that's how I got exposed to the company. Steve had started working with Gary Nelson and the team and came to me sometime later and said, hey, this is a really cool company. You should be interested in this company. And eventually he convinced me to move over from what I was doing. And so that's how I got involved.
And what were you doing up to that point?
Yeah, Steve and I knew each other from both working at Emerson, not so much in the HVAC part of Emerson, but in the process control side. As you said before, Bill, I think we come from an industrial background, working in chemical plants, power plants, refineries, things like that, and doing measurement products for these big complexes and doing a DCS, distributed control system type of work. And then, making that shift from that environment into more of a residential setting is new to us, but a lot of the measurement principles and design principles hold true.
And I would say because those big, serious measurements, we'll call them.
Yeah.
You call them DCS.
Right.
I'll call them BSMs. Those BSMs are that there's a flavor of real technical precision to what you do there. And I'm going to let Steve talk a little bit about his background and pick up on that point about technical precision.
Yeah, so we pride ourselves on technical precision, but interestingly enough, that precedes me and Bill being involved at TEC. That Gary Nelson very much had that mindset about measuring pressure, for example. Like, well, how good can we do? Not just is it good enough for the measurement, but how good can we do? And then now that we've got a great pressure measurement, could we measure tiny pressures of the combustion appliance zone, for example? So yeah, the technical precision is something that is really important in the industrial setting that Bill and I came from, but we fit right in with what TEC had been doing for decades. And I would say, you mentioned we're going to talk about innovation. I think precision is a part of that because a lot of innovation happens because now we can make a measurement as accurate as we want at a price that's reasonable. And so now what can we do with that?
So what enables you to do that? What changes have happened? And is it in the recent past, or is it about understanding sensors better sensors available, or better techniques?
Yeah, I think it can be several things, and I'm not the greatest technologist. I can tell you a couple things I'm aware of. For example, measuring absolute pressure has gotten a lot cheaper and a lot more precise because they're used in drones. And that has driven the price down and the precision up. Drones use absolute pressure to know their altitude, just like an airplane does. But obviously, you're not going to pay the same price for your drone as you're going to pay to put an altimeter in a 747. And so that's one area, is that as new technologies emerge, as measurements spread into devices that are more ubiquitous, the price usually comes down. And then you're faced with the situation of, well, what can we do with that?
Going over to Bill, so you're able to do all kinds of things, but they have to have a place. People have to have the need for it. How do you go about assessing that?
Yeah, that's one of the hardest parts of doing innovation, is understanding the innovation targets. Sometimes it's saying, what problem are we trying to solve? Because too often when you are technology focused, you become a hammer looking for nails, or you make something that's not aligned with what the market really needs, but more what you could do. And there's examples of that where you see products that are over designed for the need. People come out with things that are expensive that don't sell a lot because people say, oh, that's interesting, but I'm not sure I'm willing to spend that much. And so one of the things we're focused on when we think about innovation at the Energy Conservatory is there's a history of wanting to do things the right way. But in the building science community, some of the things that we want to do haven't been particularly easy to do. There's kind of this in culture, there's sort of like, well, you should know how to do that. Some of that's within the culture of the Energy Conservatory, and certainly in some parts of the building science community. And I think one of the things that Steve's been here longer than me that he started to bring, and I've tried to reinforce, is we should be focused on bringing everyone along if we can. Everyone can do a good job, and most people want to do a good job. So let's make it much easier to do it right. We'll never, ever trade doing it right to make it easy, because then you're not adding value. But we can do a much better job of making some of these measurements that people want to do when they're going into a home and trying to figure out what's going on and how do I make this comfortable, safer, better air quality, more durable, and all the things that people want to do in their home. How do we do that? We can make that easier. And that's what we're focused on doing.
The innovator's job is to understand what the user is trying to accomplish well enough that they can sort out the, oh, gee, that's neat, but actually not useful at all, from, gee, that's neat, and I can figure out how to make that job easier for the person using the measurement. And I've worked with a variety of engineers, and you always have a blend of different skills, but it's always good to get the engineers connected with the use of the product in the field, because then they can really understand what the user's doing. And then you can have a more productive conversation about, yeah, that's really cool, but not useful. So let's just not worry about doing that. Let's focus on this because that's what will really help.
So some examples I know for a fact, like you've done testing on your own house. We did a video together when I was doing testing on my house and you were doing testing on your house. What do you learn from those kind of experiences?
To me, the most important thing it gives me is a reference frame. When I first started the Energy Conservatory, people started, Gary and Colin are spewing out H50 numbers as if I knew what that meant. And I didn't know, is 5 ACH50 good? Is 1 ACH50 good? Is 15 ACH50 good? Well, once I did a blower door test on my own house, I'm like, okay, my house is 3.3, and that's pretty good. Now I have a frame of reference to compare it to. When somebody says my house is 8 ACH50, I'm like, oh, that's more than twice as leaky as my house. And then when I hear Gary, well, my house is under 1, I'm like, okay, so that's like less than a third as leaky as my house.
Wow.
Yeah.
Bill, have you had similar experiences hands-on?
I have done some of that, Bill, yeah, at my own house, and it does make a huge difference when you do it. I was just about to jump in. When I saw you and Gary Nelson both present on what you've done, I think that speaks, like, so many people in this industry do these tests and do this work on their own homes. I think that kind of speaks to that notion that, yes, you really become an expert when you do these things. People who are deeply committed are actually doing the work. They're not just selling products or developing products, they're using the products, and that's how you gain the knowledge.
I think relatability is what we're all talking about here. So there's been a recent, we'll say, a stronger focus on the HVAC market. So more of the traditional HVAC measurements from the Energy Conservatory. Can you speak towards that and maybe how did that evolve? How did that come about? And what are some of the things you've done there?
Yeah. So one of the first things I learned about when I came on board was this product called the TrueFlow. And Frank Spivak, who was Bill's predecessor in marketing, said, if we could make this product a little cheaper and easier to use, we could sell a lot of these, because people that used the legacy TrueFlow before this new digital version came out had rave reviews. Like, this is way more accurate. It's way easier to use. But even so, it was kind of mad scientist, a little fiddly to deal with, and hard to know exactly what the results were telling you. And so I took the initiative of learning how to understand the results and helping the engineering team drive in the direction of, okay, well, let's get rid of the tubing and put the pressure sensor on board the TrueFlow grid. And then let's see if we can make a manometer that doesn't have all the blower door bells and whistles, just for simple HVAC measurements. And let's use those two products to bring the price of the kit down to where it's more accessible for the HVAC technicians. And then let's add an app that can really walk you through it step by step with pictures to help you understand exactly what to do and what the results mean. That was the two things that I saw as the challenges to using the TrueFlow: is walk me through the process step by step, and then help me understand what I just measured.
Mhm. And the significance of it. And coming from larger company industrial background, you probably had more resources available. So innovation also has to be about, and I'm going to call it scarcity of resources, but you have to really closely manage your resources. And that becomes really tough, I'm sure, when you come up with these neat ideas that are starting to pull you away from accomplishing things. How do you manage that?
You always have to have a priority list, but one of the things that I've brought on board fairly early on when I arrived at Energy Conservatory is we set aside time just to do innovation that's entirely guided by each team member. So if one person on the team is interested in doing this kind of an innovation or that kind of innovation, whatever they want to do for that, it's not a huge chunk of their time, but we set aside 10% of their time and say, during that 10% of the time, you get to work on whatever you want. And that is our idea bed. That's our nursery for growing ideas. And then we have the hard task of trying to prioritize, okay, which of all those cool ideas do we want to focus on next? And then we build a roadmap and decide what order we're going to work on these in, and start building project schedules and driving things through the process.
And Bill, the facilities, again, working with limited resources, smaller companies, limited, but you still, in order to do this precision and being able to have confidence without too many details, but what kind of test gear, test stations, development, precision do you need? What's the equipment look like? If someone were to take a tour, what would it look like?
Yeah, well, there's a couple of different things that we work on. They're mostly focused around air measurements of either flow or pressure. And so one of the things that we have is an air chamber, for example, a NIST traceable air chamber that can measure air flows very, very accurately. And then that's used to be this source of truth. Airflow is very hard to measure and know that this way of measuring will match a second way, will match a third way. And so that's where you do come down to, there's just a few really good ways to have standards, and you want them to be traceable back to that NIST lab that tells you, yes, you're matching, you're following a process that we know is right. So you'll see that type of thing. Obviously, airflow is a big part of what we do, whether that's with a TrueFlow for HVAC market or it's for fans measuring the air tightness of a building. Those are airflow measurements we're making. And then for pressure, we have very, very accurate pressure sources, which we use to calibrate our gauges. Those types of things are what help us make sure that we're making good products. Now, I think you may have also been asking, how do you know which innovation targets are you going for? So
Yeah.
that is actually what you were asking. Okay. So how do we know? Yeah, that's where Steve says we have these guys working on innovation. But if you let every single person at a big company do what they want, they probably don't have much understanding of your markets. We have the luxury at the Energy Conservatory of having people who have been doing this for 40 years or more, and we've got a couple of them. So that's really helpful because when they want to innovate, it's because they're working on some new part of the market. Hey, these really tall buildings that are being tested now, the stack effect is a major player in the performance. We've got some crazy impacts of wind that is different on different heights, and how are we going to figure that out? They're solving real problems in the market just because, and what they're interested in because they're so steeped in our market. That's a huge advantage for us just based on the length of tenure. But then at the end of the day, all these ideas come up. Innovation is not just having great technology or just understanding a market. Innovation, like you think about really innovative companies, they have an intuition about problems and solutions that are informed by where technology is going and with unique insight on how that could solve problems that actually exist. So I think an example of that is you can measure airflow, but the real problem is, so what action should I take based on what the airflow tells me? So innovation is saying, I'm going to make it so easy for you to measure airflow and then decide, do I need to do something here or not that's going to impact the comfort of the homeowner? That's, to me, where innovation really starts to take hold. Technology, in this case, yeah, a little bit with the hardware, a lot with the app meets the need. And now you've got innovation that matters.
So you brought up app. And so that's fairly new. I mean, for a lot of products, and especially in our industry, I don't know if Steve's better to talk about this, but the app, I'm sure, had to start off at something very, very simple. And I've seen a couple iterations, but I know it continues to improve. How do you manage all that information you get from trying to make an app deliver an easy to use product, like Bill mentioned?
Actually, on the HVAC app, it didn't start super simple. I drew out my vision of what it needed to have. And our development team, we brought a new guy on board who was a good fit for this app. And he just tore it up. I mean, by the time we released, it was like, I got everything I wanted. I didn't have to descope hardly at all.
You should mention the developer is a dual major, physics major and software developer.
Yeah, computer science and physics.
That intuition you mentioned before, Bill, is baked in. Yeah.
So when we explained to him what we were measuring and what it meant, he just got it immediately, what he was trying to do. And having laid out, I put together a rough screen flow of how I wanted it to go and walked him through it. And then I've told people before, the other piece that was really important was working with Ed Jonawak, who was really the source of all the information that actually draws conclusions. How much pressure drop across a filter is too much? How much static pressure on the return is too much? How much should you drop across the evaporator coil? That's stuff, that expertise that we didn't really have at TEC. We could make all the measurements, but giving people solid advice with years of field experience, that's where Ed came in and helped inform that. And so we put all that information together with the screen flow that I had worked out. I was more than happy with even the first version of the app, and it's just gotten better since then.
Is it a blessing or a curse to be able to update an app as frequently as you want? Bill's laughing.
I think it's 90% blessing. Maybe there's 10% curse in there, but it's hard for me to see it.
You must have a feedback channel with users and staff. And you now have a training person on staff, Chris. If you want to talk about how Chris sits in the innovation circle.
Chris has been super instrumental. I mean, we brought him on board shortly after releasing the TrueFlow. And ever since, he's just really had his finger on the pulse of what technicians want the most. Normally, we know what the next 10 improvements are going to be ahead of time. It's a matter of deciding, well, which 3 are we going to do first? And Chris really has a good intuition. He's in constant communication with lots of techs in the field, super users of the app, as well as novice users of the app, and just helping us figure out what's the most important thing to do next, and then what after that, and then what comes after that.
How about from a standpoint of time to do these things? That's a precious resource for us all. Is it totally variable, or do you have certain time targets in mind?
The most important thing to do is just the basic project management stuff. You put together a Gantt chart, you sit down with a team and say, how long to do this step, how long to do that step. At least with the last couple products, the DG8 and the TrueFlow, there's always this one big long bar in your Gantt chart, which is the injection mold tool, which takes many, many weeks to get. And so you get to that point, and then that's like, once you start getting parts from the tool, you're getting pretty close to release, but you're not going to buy the tool until you're pretty certain you got it all right, because it's pretty hard to change an injection mold tool, and then they're really expensive.
Did you find any particular surprises? I will make sure the audience knows we're talking about two recent, very innovative products. Is the DG8, which is the single channel micromanometer or precision manometer, and the digital TrueFlow grid, which includes its own precision pressure sensor in it. Anything surprise you about the process that you care to share?
I'm sure there were surprises, but
I can think of one, Steve.
yeah, go for it, Bill.
Yeah, well, and first of all, I will say we should say one of the other benefits we get from Chris Hughes is he comes from the industry. It's kind of back to that same thing earlier we talked about, Bill, where you need to have people who really understand the real problems. And so I think one of the things we learned at the surprise, and Chris helped us with this, by the way, but so did some other early users of the product. We thought, hey, engineers solving problems, we're going to create this great troubleshooting product. That's the use case. That's the key. And we very quickly were told, no, that's not how I'm going to use this thing. This is a sales tool for me. And we really were shocked. We were like, that fit nowhere. And then until we learned, well, I'm troubleshooting other people's problems with this. And it's going to differentiate me so that I'm not bidding how cheap can I do a 3-ton and a certain furnace. I'm coming in and I'm doing a different looking analysis of their system. And I'm providing a quote for solving their problem that says, based on what I've done with my measurements, I'm going to do this. And Chris Hughes and some of the early users were the people who really convinced us of that. And it did change some of the way our report looks. That early use surprised us and then guided a little bit on how we decided, yeah, there's some things that we didn't think would be that important that we should address. And is this a customer ready report? That type of thing.
So this aspect of useful and precise makes me think that you're not selling products, you're selling confidence.
Yeah.
Your confidence, man.
I like that. Can we use that line, Bill? That's good.
Yeah, I mean, that's the job of any engineer that's making a measurement product. It's got to be precise. It's got to be repeatable. And I'll give you an example. One of the things that users of our products don't always appreciate is there's some of our products you can only use certain ways. An example is the exhaust fan flow meter. You can only use that with air going into the box, not air coming out of the box. And people will say, but I put it on the exhaust and I compared it to a hood and it matched. So it works. Like, okay, that means it works in one case or maybe two or three. But our job is to go through hundreds and hundreds of use cases and make sure it always works or with a very high percentage of confidence. We'd like to talk about 95% confidence on our accuracy specifications and in a large percentage of different applications. So in a flow measurement device, because they all depend on exactly how the air comes in and how the air comes out, you have to do a lot of testing, lots and lots of testing. So a technician might be very happy if they make a measurement, 2 measurements match up 3 times in a row. That's good. I'm confident. But that's not enough confidence to design a new product and have confidence it's going to work in almost all cases, or especially to figure out, okay, what are the limits? Where does it begin to not work? With our TrueFlow grid, for example, our manual says you got to have 6 inches of unobstructed space on the upstream side of the grid and 2 inches of unobstructed space on the downstream side of the grid. And that's from our testing. We do a lot of testing and we find out that as long as you've got that space upstream and downstream, you're going to get a good measurement.
Got it. What's happening in that space that makes a difference?
It's all down to which direction is the air going.
So you get circulating flow, right, Steve? You get some.
It's circulating flow, or it might just be skewing it a lot. So the true flow plate is capable of averaging out or making the flow more uniform up to a point. But if you actually get something like right up against one of the holes, it can't do that anymore. And now you've got a dead spot, and you got one of your holes is measuring a much slower airflow. So it's not just recirculation. That's certainly one problem. If it enters at a very flat angle or something just blocking a couple of those holes from the front side or the back side, that's going to throw it off.
Okay, you said something very interesting there. You said a hole making a measurement. How does a hole make a measurement?
Okay. So when we talk about the true flow grid, if you take a look at it carefully, there's actually two kinds of holes. There's the great big holes that the air goes through. And then on the front side and the back side, there's tiny pinholes that are used to measure the pressure. So each pinhole that's measuring pressure is measuring the pressure around that pinhole. And if I have blocked the big holes where the air comes through, then it's going to affect that pinhole that's near the big holes. And so it's going to throw off its ability to compensate and condition the flow.
Got it. It seems so logical now that you've done it, but putting a Bluetooth device inside to eliminate the need for hoses or wires coming out, was that just like you knew you were going to do that all along, or did that just somehow pop up?
No, I can't remember exactly how that one came up, but you mentioned surprises. And we had a pleasant surprise when we started testing that. If you know anything about radio signals and stuff, that one of the things that will prevent a radio signal from getting anywhere is a metal box, right? Well, guess what ductwork is? It's a metal box. And so we did a whole bunch of testing. We're like, oh boy, you put that in a filter slot and put a steel cover on the filter slot, you might get no signal at all out of that. But it turns out it takes no cracks at all for a Bluetooth signal to get out of a duct. And so it turns out to be a non-problem, even though we were all concerned that we're not going to get any signal through a duct.
So a little bit of history maybe. And Bill, we were talking about history on the phone a couple of weeks ago, tech history. Is it 40 years old? The company's 40 years old now?
Yeah, maybe it's in our 41st year.
Okay. And always been in Minneapolis?
Always been in Minneapolis, and it's pretty cool because Steve and I are lucky that the founder, Gary, is still involved. Certainly doesn't need to be, other than he still loves to work on this mission he created. Steve and I take stewardship very seriously of the mission he set, which is we can deliver a lot better built environments in this world. And that's what we should do. We should be developing the tools that help people make better buildings that are more comfortable and all these things. And so the fact that he's still involved 41 years later, it's a real gift, I think, for Steve and I. But we also need to take on the role of leadership from him. He's not at the point where he wants to do that. He wants to work on the things that interest him the most as an engineer and as a physicist. And so the history is great. The fact that Gary's still involved means that we get to live that history with him while we also use that to look forward. So it's a nice spot to be in.
Very nice.
Yeah, it's having Gary involved all along has just made things so much easier. Just as a technical resource, I'm still routinely asking Gary questions. What about this? What about that? Did anybody ever study this? And usually the answer is, yeah, that got studied about 25 years ago. Let me see if I can find the information. And very often he can.
Yeah, or if he can't, Colin Olson, who has also been with the Energy Conservatory a long time, usually has it.
Yeah.
So Minneapolis, your facility there, you also do training, live training with people? Do you invite people in? What's that all about?
We began doing train the trainer events maybe 6 or 7 years ago, I want to say. And originally, we just opened it up to everybody, and we'd end up with a mix of a certain number of like HVAC instructors, but then we'd also end up with training people from weatherization and energy rater programs and organizations. And those two groups of people are a little tricky to train together. So we decided we're going to split it up, and we're going to train the HVAC instructors separate from the people that have been doing blower doors for decades. And so that's been successful separation. We'll have our first home performance or blower door focused training coming up here soon.
But blower door crosses over for HVAC.
Yeah, I should say our weatherization and energy rater focused one is, I think we're still getting that scheduled.
Very good. And there are other training materials or a way you share the knowledge that you have. Bill, you want to talk about some of those things, being a marketing guy?
Yeah, right. Yeah, nice setup. Thank you. Well, first I'll say what we try to do is have people from the industry. I mean, that's been kind of a theme. So we've already talked about Chris Hughes. He kind of runs our HVAC training. And as Steve said, he's running his second Train the Trainer now. He's got a lot of videos that he and Ed Jonawak have created, along with you, Bill, and Steve, where we've got, hey, how do you measure HVAC airflow, but also other measurements you make as an HVAC person related to building science. So Chris Hughes kind of is the lead for that because he's got 20 years of industry experience. On the building performance weatherization side, we've got Jake McAlpine. Well, Jake's got 12 years experience as a weatherization practitioner out in the field doing the tests and then also running the program from Minnesota. He's a graduate of the University of Minnesota Building Science program. And so we try to really make sure that the people leading our training, leading our support for the markets that we serve are led by people who understand them, who lived in them, and then bring that perspective back to our technical team. And that's how you innovate. That's how you solve problems and make things better.
You have a website for some resources as well as videos and things like that?
A marketing guy should mention his website, right,
You
Bill?
should.
He shouldn't need to be reminded twice to mention that he's got a website.
I am digitally kicking you under the table.
What's wrong with me? Yes, thanks, Bill. Yeah, this website that we have for the Energy Conservatory, energyconservatory.com. Out there, you'll find links to all sorts of training and application guides, whether you're doing single family blower door tests or duct tests or multi-family or large commercial building testing. As I said, HVACairflow.com is connected to that. So that's a great resource for HVAC measurements. So yeah, all that's out there and a lot of video connections out to YouTube where we've got quite a library of free videos. We've got a free LMS training where it's got quizzes and modules built in that you can sign up and have access for 30 days. All that comes from when you start looking at training on our main website.
Got it. Very comprehensive there. And you guys are at trade shows, some of the trade shows you go to. Want to rattle those off? Just like, where can people find you guys in person?
Bill, you got the list in your head?
Oh, for sure. Of course, Home Performance Conference.
Yeah. Bill just tells me where to show up.
Interestingly, you can find us in 2023 on the virtual ResNet conference. So that's kind of the big news. We're not going to be at that conference except virtually. And so that's an exciting change there. But Home Performance Conference, we're at a lot of like HVAC Excellence, HVAC Symposium, and then a lot of builder shows now with like the BS and Beer series that's going on. So we're there. I think we're actually going to be doing some things at the Radon with TrueTech at the Radon conference this year. And then a lot of regional weatherization trainings. We support a lot of those as well. We'll be at EBA and Greenbuild, I believe, this year. So we're really, right now, we're with all the conferences coming back, this year will be a very big conference year for us.
Yeah. Things are heating back up again. In conclusion here, what's the biggest takeaway about these pressure and airflow measurements that you'd like to leave our listeners with? And remember, we get a mix of both weatherization and HVAC listeners.
I'm trying to think of a key takeaway. I think let us know what you have trouble measuring. As Bill mentioned, innovation comes from understanding what the market needs. And we're aware of certainly a number of things, directions that we have on our innovation list, but there's undoubtedly some fairly significant problems maybe we haven't heard much about. So don't hesitate to reach out to us and say, I got this kind of pressure airflow related thing that either I don't understand what's going on or I need a tool that can help me measure this way or that way. That's one takeaway is reach out to us and let us know how we can help you.
Very good. Bill, from you, anything?
I'll just say that I think what you'll see for our direction is we're hoping to see you've got HVAC, you've got weatherization, you've got home performance. And we're hoping that over time, all of these people become people who deliver better built environments. They're all in the home. They all bring a perspective and a specialty that's different, but all of them have, we shouldn't ever complain. Why don't these people understand more about how the house performs as a system if we haven't made it easy to do that? And so that's really what drives us is we really should make this easier. If we want to live our mission, we got to make this easy for everybody. So let's make these measurements easy, but more importantly, let's help them understand the diagnosis and what actions should be taken so that they leave that home better than they found it.
And a lot of that comes through the communication that you're engaging in, because sometimes you can have these great ideas, even if you know them, but people have to know how they impact them and what you're doing. So that's part of why we're talking today. If somebody does have the next greatest idea or problem they'd like to see you solve, what's the best way to get in touch?
I would say email either one of us or just give us a call. Jake and Chris are good at, they may know that maybe we've already helped to solve that one and we've already got a way to do it. So Jake and Chris, or you can email me or Bill. I'm srogers@energyconservatory.com. And go ahead, Bill.
Yeah, bgraber@energyconservatory.com. And as Steve said, Jake and Chris are really out front. They're always coming to Steve and I saying, I was talking to this gal the other day and she had this problem. That is a lot of how we get into these. Next thing you know, 2 hours have passed and Steve's on the whiteboard with a lot of ideas with Chris or Jake really working through what users are seeing.
Very cool. Thank you, Steve and Bill, for this time today. And I hope the listeners got something out of this. And I'm really proud TruTech's affiliated with the Energy Conservatory and seeing especially some of these new things you've been doing the last couple of years. And I know that takes a lot of effort beforehand. I want people to appreciate the effort you put in, and you're always thinking. You guys are always thinking. So thank you.
Bill, we appreciate you too. Thanks for all you do for TEC, but for the industry. Thank you.
You're very welcome.
Yeah, thank you very much for having us on today, and thanks for everything you do. And we look forward to many years of working together to trying to get the message out there.
Absolutely. Thank you for listening to this episode of the Building HVAC Science Podcast. There's other trade-related resources and influencers out there, including the HVACR School, HVAC Shop Talk, HVAC Reefer Guy, Stephen Reardon, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, and HVACR videos, and also HomeDiagnosis.tv, which is the first TV show on home performance, and of course, basically anything you can learn from Jim Bergman on the Measure Quick YouTube channel or wherever he shows up in other podcasts. I also host the Res Talk podcast, where you can learn more about the world of home energy ratings and peripheral related topics. If you like what you heard today and you've not subscribed to the podcast, please consider doing so by typing Building HVAC Science into the search bar of any one of the typical podcast apps. There's so many out there now. Well, thank you for joining us, giving us your ears and listening into this episode. If you're interested in reaching out to me, you can reach me at bill@truetechtools.com. The Building HVAC Science Podcast is a production of TrueTech Tools Limited. You can find our website at www.truetechtools.com. You'll also find all the fine products by the Energy Conservatory, the guests on our podcast today. Thanks again for listening. Take care.